Okay, so we move on to topic 6, which is testing, troubleshooting, and final documentation. Which is this is the last topic of we have all 6 topic discussing about theory of the electronic equipment design, and in this 7th week of lecture, we have arrived to the final topic, which is topic 6, so that after that we can focus on completely on the demonstration of some practical demonstration or practical lab. So we'll be discuss more on the later on, which is from starting from next week, after the week after the holiday. All right, the week after the midterm session, midterm break, we will move on to this more focus on the discussion about practical lecture, and also I will be also guiding you on how you can do your mini project as well, and also you will need to answer some of the assessment that will be given later. All right, so for this topic, basically it has some objectives. So a lot of objectives here as written here. So basically um, animation, slideshow. I'm going to stop these timings. Okay, so okay, back. So at the end of this chapter, I hope that all of the students will be able to, the first one is understand the 4 basic testing and troubleshooting procedures. What are the 4 basic testing and troubleshooting procedures, or the troubleshooting steps that should be taken when we do the testing and troubleshooting? So we'll have a look at it later. So the second one is understand the testing and troubleshooting flowchart. So basically, when we do the troubleshooting and testing, we will follow on the guideline, which is the flowchart, which is the procedure that we have to follow step by step. Whether or not doing the troubleshooting or not, for example, we will start with preliminary test, okay, which is the third objective is the student will be able to perform some preliminary tests without project burnout. Okay, and then number 4, perform operational test. After the preliminary test, there is the operational test that you need to do. Then number 5 is use the human sense. We have 6 sense, 5 sense, right? So using the human sense, like smelling, touching, something like that, to troubleshoot the circuit. Okay, right? Then number 6 is to do performance testing and write the test result documents. Number 7 is write a summary and recommendation document. Number 8 is compile the final project report. So basically, these are all of the objective. I think it's too much. I need to review this. This is basically it's not. This has been prepared by the previous lecturers, so I have to follow it. But maybe I'll need to revise this. It is stated here one by one, each of the objective for each of the slide, I guess. So I'll need to revise it later, but basically you hopefully that you will know all of this. The first one could be something related to steps of testing and troubleshooting, okay, and then the second one will be related to much more on the documents. All right, so which is how to prepare the test result document, and also the summary and recommendation document. Okay, so that 2 things basically you need to understand to in this topic 6. So basically we have only 2 units, but only 2 units to be covered on top of the 8 objective we have overall. But basically uh, we will cover on 2 units, which is 6.1 is related to testing and troubleshooting, and then 6.2 is the final documentation. Okay, so we'll start with 6.1, which is testing and troubleshooting. So what we are going to do For example, when we finish the project, our prototype, once we finish it, what we need to do is to start testing and troubleshooting. So sometimes there will be no need for us to do the troubleshooting, just to do the operational testing, and uh, our design or our project functioning uh, as expected. That means that there will be no need for us to do the troubleshooting, except when we have a check and then we do the operational test, and once we notice some error, some trouble, or some burns of the component, for example, then we need to do the troubleshooting. So basically when we do the troubleshooting, there are four procedures that we can follow. The first one is to perform the preliminary test. Okay, we will start with the preliminary test, which is in the preliminary test. Basically, I will explain it later about each of the step here. Okay, so firstly, what we do is to perform the preliminary test. After the preliminary test, then we proceed to the operational test. So basically, for the operational test is much more to the test when we connect our project or our prototype with the supply. Okay, when we supply this prototype uh, from the supply voltage, then we operate it, then we observe. All right, so that is about operational test. Then if during operational test you encountered some uh, problems, okay, we notice some problems, okay, that we need to do the troubleshooting. So if we notice a problem from operational test, what we need to do next is to do the troubleshooting to find out the root cause of the error or something that makes our project faulty, right? So that, and then after that, once we finish doing the troubleshooting is something like a loop, right? So we will do the troubleshooting until uh, uh, we are satisfied with the operation, which is the project works well without any issues. Then we will proceed to the performance testing. Okay, so as the performance testing is the fourth step, which is the final step. Okay, evaluation is not related to this four procedure. Evaluation is much more to the, it is raining again. It is dark outside. Right. So evaluation is much more like something that the final decision that we can make before we do the production stage, which is the, if you want to do the mass production, if you want to do mass production, then we decide at this stage. This is the evaluation. Okay, it start raining, and can you hear the rain? Okay, next, I hope the there will be not flooding, because we have experienced flood at UMT in 2014. There was a big flood at the UMT. So next is about preliminary testing. Okay, so for the preliminary 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 testing. Okay, for the preliminary testing, what we need to do is to perform it before we apply any voltage, before we connect our project or our prototype to the supply. Okay, so what we do is to just observe. Okay, we take our, for example, this is our prototype. In the preliminary testing, basically what we do is just to observe, is there any wrong connections, uh, is there any wrong placement of the component, right? Is there any loose of the wires, for example? Okay, So we check the continuity of the wiring. For example, we can do the continuity check using the multimeter, which is something that I've shown you before. Before you switch on or provide supply to this prototype, for example, so what you need to do is to check the connections, the connections, continuity of the wiring. So what you can do is just to move the dial to the something that you can hear the sound, something like that, which is you need to place the probe to common and resistor level, not the voltage level, the voltage one. And then what you need to do is to check the continuity. For example, if I want to check the continuity of some parts of this PCB board, you can hear it. So that means the connection of that two part is no problem. Okay, that sort of thing you can do by referring the circuit diagram or schematic diagram, and you can do the continuity check before you give some voltage or to the component, to the PCB board that you have put. So in the preliminary testing, basically what we do is to catch errors, assembly errors, for example, that will result in the serious problem. So of course, before we connect any supply, we want to avoid something that will be burned out, that component will be burned out, for example, something bad smell or pop. Okay, pop means something that explosive, something like for example, if you apply more current than the rated current to the component like capacitor, it will pop, which is there will be some explosive, right? Okay, so and then to preventive testing, better safe than sorry approach, which is yes, we want to prevent something bad to happen later, so that we will do the preliminary testing. Okay. Then construction errors. Basically, for the construction errors, we can follow this sort of procedure. For the construction errors, okay, this is the procedure for the uh, check for the construction errors. In terms of, it is divided into either wiring mistakes or the incorrect component placement. So when checking the construction errors, basically we check the wiring or the component. In terms of wiring, for example, we will check whether the wire is going where it shouldn't go. For example, sometimes we mistakenly connect the wire from active terminal or from voltage terminal or live terminal to the ground, for example. So some inspection in terms of wire missing, and then wire bed or open wire which is not completely joined or connected, and then faulty wire connections, right? Then in terms of component placement, also we'll have to have look closely to check whether or not the component is placed to the right place. Sometimes for the 3 leads component, like transistor for example, it is accidentally placed in the voltage regulator, which is also the 3 leads component. So sometimes, okay, something like that. Then some component might be placed in a backward direction. For example, as you can see, component like IC, you have to be careful because where is the IC? This pop-up is disturbing, quite quite annoying. Okay, I just quit. This one. So this is the IC. So basically, as you can see, the IC is something like this. It has some leads. For example, the rotation. of IC is something like this. It has something like head. For example, it marks this mark like the round mark here that shows this is the first pin. Okay, and then the rest is second, third, and fourth pin, and then straight goes to the other side, which is number 5 pin, 6, 7, and 8. So basically, as you can see, number 1 is for grounding, number 8 is for the VCC or power supply. So if we accidentally place this IC in a wrong direction, meaning that, for example, suppose that connection should be ground, but you have connected that connection to the control voltage. So if you connect this ground to the control voltage, what happens when you supply the voltage, and of course when the voltage is touched to the ground, it will burn. So we want to avoid burns or faulty or failure of the IC. So please make sure that you place the components correctly. And then some color-coded components like resistor, we can easily mistakes. All right. For example, 1 kilo ohm resistor, supposed to be that place is for 10 kilo ohm resistor, but we mistakenly we wrongly read the color code of the resistor, then we accidentally place the 1 kilo ohm. Suppose it's to be 10 kilo ohm, but we place with 1 kilo ohm, right? And then another components like electrolytic capacitor, diodes, and also IC, which is easily to be mistakes, which is in wrong component direction when you place it. Okay. All right. So next is after the preliminary testing. So next is what we are going to do in the next step is operational testing. Okay. So in the operational testing, before that, in preliminary testing, we do not connect any supply. Okay, we don't give any supply to that PCB board our project. But basically, we just observe, right, without any supply. But for the operational testing, we will start to give supply for this. For example, this prototype, we will give this supply to make sure to confirm that this design or this project is operationing or not. All right. So basically, when we connect the supply, the power supply, we can use the isolation transformer. Okay, isolation transformer is the equipment that can isolate. Okay, can isolate the supply to the component. So we use this isolation transformer for the purpose of protection. All right. So when we have this isolation transformer, we can avoid some unnecessary inrush current. Inrush current means the unnecessary surge of current. Okay, we want to avoid something that can give problem to our project. All right. So in operational testing, basically we can use the isolation transformer, and then before we do the performance testing, we play around a little bit with the project, just let it warm up. So every electronic component, it needs some time to warm up. For example, a capacitor is uh, capacitor or inductor, for example, it needs some time to before it achieves to the steady state. All right, so we will have to warm it up, right? Like our PC, our computer also. Once we start up or we boot the computer, of course we will need to wait some time to make sure that all of the applications, all of the system loaded with all of the application, right? So basically we will need to let it warm up first about maybe some few seconds before we do the operational testing. And then uh, we determine the functionality of the project or the prototype that we have, determine if anything may be wrong, and then we perform extensive evaluation what is going. And then if all of the testing in terms of operational testing is fine, so we can do the performance testing. Okay, so if anything gone wrong, what we need to do is to do the troubleshooting, then to correct the error. If there is no problem with operational testing, then we can proceed to the performance testing. So if anything problem during the performance test, during the operational testing, if anything problem, like we notice something that has been burned out, for example, suppose we want to produce some sort of result like a display, for example, but it was failed to display. Okay, sometimes when we switch on, then we do the operational testing, something bad smells coming out from this project. So what we need to do is to find out that error, which part has that sort of problem. Okay, so we do the troubleshooting to determine what is wrong, what we need to do, in correcting or fixing that sort of problem. So we want to identify the root cause of the problem. Then, so basically, when we do troubleshooting, of course, we will need to have a check and then again and again. For example, sometimes for the experienced person, they will know which part is failure, which part has got failure, right? Sometimes we need to do some follow some procedure to do the uh, something like constructive troubleshooting. Okay, so this troubleshooting is happen like a loop. Okay, meaning that we will need to repeat this until we are fully satisfied, until everything is good, which is operational like we are intended, something like it is operation correctly or operation normally operate normally. So we can quit troubleshooting. So basically we will do troubleshooting until we are satisfied that the project or the system that we have built uh, operate like something that we have intended. Okay, so basically in troubleshooting we can use this four human senses. This four human senses is useful when we do the troubleshooting, like sight. We use your eyes to have a check, have a look closely, which components have already burned out, right? So you can just observe, for example, some bad component like capacitor, like something burn out for this component. Like this component has been burned out, so we can notice this. And then smell. Okay, we use sniff around transformers. For example, transformers got some construction, some component which is we call it as insulated linings, which is when the transformer burns, it will produce some smell. Okay, so sniff around the transformer uh, to to check is that transformer has already burned out or not, right? Then listen up using your hearing. to listen up. For example, the pop sound, pop sound that indicate loss of wire. So when you connect your project to the power supply, when there is a loss of wire, it might have some pop sound. Okay, pop, something like that. Then touch, just you can use your finger to touch some, for example, like solid state component like transistor. When it is operating, meaning that you can feel something like a bit hot, a bit of warm. All right. If too hot, meaning that the component is probably failure. All right. For solid state component, as I told earlier, like transistor, for example, when it is operating, you can feel like something like warm. Okay, you can feel warm. If it is cold, meaning that there is no supply connected to the that solid state component. Component substitution. So if anything wrong with the component, you have to replace that component. You can completely remove it. So this is where it comes the unsoldering or desoldering process. You have to do the desoldering process to take out the component, the bad component or the failure component. The failed component, then replace with the new one. Okay, and then after you finish, you have done all of the troubleshooting procedures, and you have confirmed that your circuit or your project perform like intended, which is operates normally. Then you can do the performance testing. Okay, so performance testing is basically referring to the testing in terms of the real world. We want to see the real world condition, the real world operation of that component. For example, if we design the prototype that we are going to use outdoor, of course, when we do the performance testing, we want to check it whether or not it is successfully operated in that real world condition, meaning that when we use this outside, so it will perform as usual. That sort of performance testing. Sometimes we playing the critics, like we question ourselves. Okay, we constantly question ourselves to the test results, and then never give your stamp approval until you are absolutely sure. Meaning that if you are a technical person, professional person, like professional technologies or professional engineers, when you do the inspection or do the performance testing of the some equipment or circuit or prototype, so never give any stamp, never give any stamp approval, for example, if you are not satisfied with the performance. Right. So before it can be mass produced, make sure it is performing like we wanted it to be. Okay, so giving the project away means that we hand this project to another potential users, meaning that if we are designing the project for kids, then we will pass it to the kid for them to test it. Okay, then the second part. So far we have finished the testing and troubleshooting part. We have discussed in detail about the steps that has to be taken when we do the testing and troubleshooting, which is preliminary testing, operational testing, troubleshooting, and also performance testing. Okay, that four step has been discussed in detail. Now we are going to move on to final documentation. So in final documentation, basically we will need some two final documents. As you can see, the first document is the test result document. All right. The second document is summary and recommendation document. So we'll be discuss more on this later. And then coming along with these two document, we will need to prepare also the final report. All right, the final report. So when we're preparing all these two documents, basically we need to record in terms of photos, illustration, tables, and reference that we can put in the appendix, for example. Like basically in terms of photos will be important when we preparing this sort of report or draft or about this summary and recommendation document. So basically, like I have instructed to all of you to make sure that when you do the mini project, make sure that you record in terms of photos, videos, right? Make sure you have, for example, you can have a logbook. Okay, write your notes. Write your notes when you do the mini project. What is wrong with that project? For example, you need to, because it is important when we do something, we will need to write some notes, right? Okay. um so for the first one is test result document, which is something that looks like this, as you can see in this figure. This is part of the 2 pages test result documents. Basically the final test result document, which is something that looks like this, 2 pages of test result documents. So this is an example of the test result document. As you can see, it is explained in detail in the test result document. So it records the result of the test and troubleshooting procedures. Just something like this. It's more to something like checklist. This is not something like for example, in your thesis, you present result in thesis is different, right? So for this sort of project, okay, electronic project, for example, you present the result in terms of something like this, which is the reporting should looks like this, which is something like checklist, and checklist and some comments that you can include for each of the items in this report, in this test result document. Then basically the structure or the construction of this test result document, it consists of 4 steps of the testing and troubleshooting procedures, which is starting from the preliminary test result, and then operational test. Then next is troubleshooting result, and also the fourth one is performance test result. So basically it consists of 4 major steps in the testing and troubleshooting procedures. The first place is the project name. As you can see here, the project name of project, which is the 3-channel color organ. And then followed by the person who performed that test. Okay, the name of the person who provide the test. Okay, who carry out the test. And then following with the preliminary test results. So as you can see in this section, this is the preliminary test result. For example, are all wiring complete and correct? If it is yes, then you mark it yes. Then when you mark it as yes, then you will have to put some date and also the initial. INT is initial, right? And then all the soldering connections are good, and then you have checked, and then mark your initial here with the date. Okay. Next is once you finish the preliminary test result, then you will proceed to the operational testing, okay, which is this one, the operational testing. Is there any catastrophic failure? Is there any minor problem? So if it results in the catastrophic failure, for example, you will need to put some notes here. You need to put some comments or explanation. Okay, if yes. If no, then mark, check it no. Okay, then initial. And then any minor problem, any calibration is necessary. Calibration means something that we do the confirmation in terms of rating, in terms of specification of the project with respect to the reference. Like for example, if we do the audio system, then once we finish the prototype of the audio system, we are going to check it, to calibrate it by comparing to the performance of the standard one. All right, that is the calibration. Next is troubleshooting. Will be necessary or not? Okay, if it is necessary to do the troubleshooting, then you will need to fill up the troubleshooting result. Okay, so this is the troubleshooting result. And then finally the performance test result, and also the concluding remarks or concluding comments. Okay, so for the concluding comments, it is not something like opinion. It is much more to the summary of the result that you have obtained. You provide the summary here. It is not a comment. You cannot comment on this project. Basically, you provide a summary, right? Okay, this is the overall look of the test result document. It has 2 pages, which consists of the 4 elements of 4 steps of testing and troubleshooting procedures, which is start with preliminary test result, operational test result, troubleshooting if available, and then finally the performance test result. And then finally the summary and recommendation document. Some things like when you write a thesis as well, at the end of the chapter, the end chapter of the thesis, basically we provide the conclusion and recommendation, right? So in this case, we write down the summary and recommendation document. So it is a brief summary about our project. And then the recommendation, which is what is the things that we want to recommend. Okay, like we have done the prototype version 1, for example. So when other people wants to build another prototype which is very similar to this one, which is for example the version 2, what sort of recommendation that they should provide in that version 2 of the prototype. Okay. So basically for summary and recommendation document, it only have 1 or 2 paragraph, not much, in just one single page, at least 1 or 2 paragraph that simply state the goal and objective. Okay. Sometimes when somebody have a check on the project, they are not going to check on the result document, but basically they will jump to the summary and recommendation document first, which is basically they would like to know about the overall result first. Okay, before okay, so that is why the summary and recommendation document is important. So make sure you write it as a summary, not as something like comment, for example. So basically, it is summary of overall test result, overall observation, overall procedures that you have made. Then you put in the summary and recommendation document. So basically, in the summary and recommendation document, it should have some basic possibilities. For example, the first one, whether or not, for example, the first one, you can say that if the prototype is worked perfectly, meaning that you can provide a statement that the prototype worked as expected. Okay. For the second one, for example, the prototype works, but further performance testing is required. Okay. This is not too bad. The third one is the prototype needs the following modification, meaning that you provide report, and then in the summary and recommendation document, you write down that this project need to be modified. Okay, because from your test result there's some failure, for example, that you need to do the troubleshooting. Then after that, that project must be modified uh, to okay. Then number four, this is too bad, which is the prototype has not performed satisfactorily, meaning that your project has failed, right? So this is the final example of the summary and recommendation document. As you can see, there is a title, 3-channel color organ by somebody, okay, a person or the group that have done that project. And basically you state the summary and recommendation documents, start with the goal that has been achieved, your objective has been achieved, then you have done the sort of testing, for example, and the product or the prototype has satisfactorily works as you intended it to be, right? Okay, so all right, so we have finished all of the theoretical lectures. I think I will be releasing 2 quizzes later. Maybe from next week, you will see that quiz 4, sorry, quiz 5 and quiz 6. Huh? So I think it's finished now. So any question? I would like to finish it early today. If there is no question, then we will finish this up to this time.
Tak ada question, tak ada.
Tak ada.
Tak ada.
So okay lah, saya boleh balik ah. So it's raining heavily now. It's like a dark, very dark outside. So saya kena balik lah sebelum banjir, right? So see you next. See you this week in Thursday in our practical session, right?